everyone, it's Olivia here from Olivia's Online Tuition, and today is day 7 of my 25 days to a better maths grade series, and today we're looking at completing the square. So as always, we do some example questions first and on to exam questions. Let's get to it. Okay, first up then, write x squared minus 6x plus 1 in the form x plus a all squared plus b, where a and b are integers. So this is a telltale sign of completing the square. If I want you to write it in this format, it is always completing the square. There is nothing else it could be. This is completing the square, right? And then how I complete the square is I've learned this little formula. So it's always going to be x plus or minus whatever half of b is, all squared, take away whatever half of b is, again, all squared, plus c. There you have it. And then you just fill in your numbers. So x is a is 1, as always, but there's no a's in this, so it doesn't really matter anyway. B is minus 6, and C is 1. So same layout as you would labelling like the quadratic formula, for example. And then let's fill it in. So we get x, it's going to be then half of b, which is minus 3, all squared, take away, and then what is that? Half of b is minus 3 squared, which is 9, and then plus 1. And then we get x minus 3 squared minus 9 plus 1 minus 8. And that is your final answer. X minus 3 all squared minus 8. And then, moving on, hence or otherwise, write down the coordinates of the turning point of the graph, y equals x squared minus 6x plus 1. So they say hence or otherwise. You could do some like really weird algebra stuff. You could plot a realistic graph if you really want, like a to scale graph if you wanted to. It would take you a long time and would be completely nonsensical, but to me you could. That's why there's a hence or otherwise. But hence is the word you wish to go for here. So essentially all you need to do is change the sign, keep the sign. Change the sign, keep the sign. Change the sign, keep the sign. So you change the sign on the first number, so it makes it 3. Then you keep the sign on the second number, which is then minus 8, and that always works. Change the sign, keep the sign. There we are, that's the first question. Okay, next up then, write 2x squared minus 12x plus 23 in the form a lots of x plus b all squared plus c, where a, b and c are integers. So we notice here there's a little 2 in front. Quite rare, doesn't normally come up on a higher paper or any paper for that matter. It's normally like an add maths or a further maths kind of thing, but if you're looking at completing the square, chances are you're probably going to be looking at that as well, like the further maths stuff. But if not, so it's good to practice because it is on the syllabus, it's just not as common, right? So what we do with this one is we first get rid of this 2. So what I'm going to do is factorise it out, but of just the first 2 terms. Always the same, if you've got a number in front of completing the square, just take that number out of the first 2 terms. So we can then get x squared, and then take away 6x. This divided by 2. Close my square brackets, plus 23. I use square brackets because it's like not something we normally do, right? We don't normally just factor out of 2 terms. To tell myself that we don't normally do this, I'm going to use square brackets. And then we complete the square just on the inside. So by completing the square formula, that is x plus or minus a half of b minus a half of b squared. No c in this case because there's no c in here. And then opening it up again, so we then get x and then half of this, that's minus 3 squared, and then minus half of this all squared, which is 9, because minus 3 squared is 9, and then brackets plus 23. And then what we need to do is get rid of these square brackets then, so times it out, that times that, we get 2 lots of x minus 3 squared minus 18 plus 23, and then bring these 2 together, 2 lots of x minus 3 squared plus 5. And there we are. And then, hence or otherwise, write down the coordinates of the turning point of the graph, y equals 2x squared minus 12x plus 23. So nothing changes here. It's still the same method for this little bit. So change the sign, keep the sign, 3 minus 5. Change the sign, keep, plus 5, can't see. Change the sign, keep the sign, 3, and then plus 5, and that's it. Okay, last example question then. By completing the square, solve x squared plus 10x minus 3 equals 0. So we're going to complete the square first and then deal with the equals bit, giving our answers in Z form. So let's remember our equation for completing the square. So x plus or minus a half of b all squared, take away a half of b squared plus c. Let's put our numbers in then. So then we have half x and then plus or minus whatever half of b is. So b is 10, so we're going to half that and get plus 5 squared. Take away half of b, which is 5 squared, plus c, which is minus 3. So plus minus, or just minus 3, equals 0. And then we've got x plus 5 squared minus 25 minus 3 equals 0. And then simplifying this, x plus 5 squared minus 28 equals 0. Okay, so I've fully completed the square, and now we need to give our answers in third form. So what I'm going to do with this is add this over here for now. So I'm going to do x plus 5 squared equals 28. And then I'm going to square root it. So get x plus 5, and then be careful, plus or minus square root of 28. Because it could be either a plus version or a minus version. Be very careful of that. They will trip you up, so be very, very careful. And then you take away 5. So then we get x equals minus 5 plus or minus the square root of 28. And that is your final answer. That's both your solutions. So easy peasy. You just add the number over, square root it, remembering your plus and minus signs, and then take away the number. Hey presto. Okay, first exam question then. This is the Edexcel November 2017 paper 3, which is a calculator paper. So it's just completing the square, just plain and simple, that's all it is. So then bring your formula, pause it, have a go, see how you get on. Okay, then question 13. Write x squared plus 6x minus 7 in the form x plus a all squared plus b, where a and b are integers. So remembering your equation, so we get x plus or minus a half of b minus a half of b all squared plus c. And then that's a, that is then b, and then minus 7 is c. So then we have x, and then half of this is plus 3 squared. Oops, daisy, got that squared. And then take away 1/2 of b, which is 3, square it, which is 9. A lot of 9s today, isn't there? And then plus minus 7. Okay. And then we get x plus 3 squared minus 16. And that is your answer. X plus 3 squared minus 16. And there we are. Next up then, another Edexcel question, this time from June 2019, paper 1, which is non-calculator. So pause it, have a go, see how you get on. Okay, question 19. Given that x squared minus 6x plus 1 is equal to x minus a all squared minus b for all values of x, find the value of a and the value of b. So remember, whenever you see this format in your exam paper, it's always going to mean completing the square. Always, right? And then let's have a go at doing that then. So remember your formula, x plus or minus a half of b squared minus a half of b squared plus c. And then this one's going to be b, this one's going to be c. So we then get x minus 3 squared. It's always minus 3, isn't it? And then minus half of that squared, which is minus 9. And then plus 1. And then x minus 3 squared minus 9 plus 1, that's minus 8. So then a is going to be 3 and b is going to be 8. No negatives because there's negatives already up here, so this one's just the value of a and b. And if these were negatives as well, it would be like a minus situation, which wouldn't really work. So 3 and 8. And then hence write down the coordinates of the turning point of the graph y equals x squared minus 6x plus 1, which is what we've been given up here. So remember, change the sign, keep the sign, change the sign, keep the sign, change the sign, keep the sign. So we then get 3 minus 8. Ta-da! Okay, next up then, a multiple choice question from AQA this time. So AQA November 2017, paper 1, which is non-calculator. So yeah, it's a multiple choice question. Pause it, see which one you reckon it's going to be. Okay, then question 23, the equation of a curve y equals x plus 3 all squared plus 5. Circle the coordinates of the turning point. So turning point, remember, is that change the sign, keep the sign. So it's going to be minus 3, 5, which is this one here. Okay, next up then, a two-parter from AQA, which is June 2018, paper 1, which is non-calculator. So pause it, see how you get on. We'll go through it in a second. Okay then, so question 27a. Jo wants to work out the solutions of x squared plus 3x minus 5 equals 0. She says the solutions cannot be worked out because x squared plus 3x minus 5 does not factorise to x plus a, x plus b, where a and b are integers. Is Jo correct? Tick a box. So, is the only method of dealing with quadratics factorising? No, it is not, right? So no, because we could complete the square, hence why I'm putting it in this video, or you could also use the formula, quadratic formula, either or. So no, as Jo could use the quadratic formula, or, so you don't need both, I'm just putting both because either or you could have, or complete the square. Okay, and there we are. And then 27b, without expanding any brackets, show how to work out the exact solutions of 9 lots of x plus 3 all squared equals 4. Give the solutions. Okay then. So we need to rearrange this to get x on its own. So the first thing I'm going to do is divide by 9, right? Because to get rid of this out here. So then we're going to get x plus 3 all squared equal to 4 divided by 9, which is 4/9. And then I'm going to square root. So I'm going to then get, don't need that anymore, x plus 3 equals plus or minus the square root of this, which is square root top and bottom, 2/3. And then take away 3, we're going to get x equals minus 3 plus or minus 2/3. Let's work out what that is, so might as well, 3 marks worth. Let's do then minus 3 plus 2/3. That's minus 3/1. Put its fraction, make it into a fraction. And then we could do, what is that? Times it by 3 minus 9/1. Can't really see it, let me move it down a little bit. There we go. Minus 9/1, over 3. Oops, it is plus 2/3, which is 7/3. So one solution would be 7/3. And then let's do the other one. So then we get minus 3 minus 2/3. Do the same thing to it. Then we get minus 9/3 minus 2/3, which is minus 11/3. So you get one solution is 7/3 and the other is minus 11/3. And then we have 3 marks. Okay, next up then, another AQA question. AQA June 2019, paper 1. And a little bit trickier this one, so pause it, have a go, see how you get on. Okay, then question 26. The turning point of the graph y equals x plus a all squared plus b has the x coordinate minus 2. 3, 1 is another point on the graph. Work out the y coordinates of the turning point. Okie dokie then. So, this x coordinate here, so coordinates will be like this, right? So minus 2 something, whenever the y one is. So, putting this, if we kind of reverse it, put it back into here, what would we get? So, we would get y equals x, and this one you change the sign, so change it from a plus to a minus, so it would be x plus 2 all squared plus b, or whatever y is, b and y being the same thing. But don't want to make it y, that's going to get confusing for that one. So then we need to figure out what this b is, right? So we can use this one to work that out. We can put this point into here as well. So x being 3 and y being 1. So then we get y, which is 1, equal to 3 plus 2 squared, plus whatever b is. And then we can have 1 equals, that's 5 squared, which is 25 plus b. So then b is equal to, take that over there, minus 24. So there we are, minus 24, and that's it. Hey presto. Okay, next up then, another AQA question, June 2017, paper 3, which is calculator. So pause it, have a go, see how you get on. Okay then, question 23. Here is a sketch of y equals x squared plus bx plus c. The curve intersects the x-axis at 5, 0 and point P, the y-axis at 0, minus 10. Okay, work out the x coordinates of the turning point of the graph. So I'm going to shrink this a little bit so I have a bit more space to write. Still the same question, obviously just shrunk. So let's have a look then. Let's see what we've got here. So the x-axis at 5 noughts, that's that bit there. And then the y-axis at 0 minus 10, that's that bit there. Okie dokie then. So we know that C is going to be minus 10 because that's the y-intercept, isn't it? So we then have y equals 2x squared plus bx and then minus 10. Okay. And then we also know that this point here is also on the line, this 5 naught. So let's put that in so we can figure out what b is, right? So then we know that y is going to be 0 when x is 5. Let's put that in. So 5 squared plus b times 5, which is 5b minus 10. So then 0 is equal to 25 plus 5b minus 10, which is 0 equal to 15 plus 5b. Take 15 over there, minus 15 equals 5b, divide by 5, minus 3 equals b. Okie dokie then. So now we've got our full equation. I'm going to put that up here. So now we know that it's y equals x squared minus 3x, minus 10, okay. And then it wants the x coordinate of the turning point, so that means completing the square, right? Let's write out our equation. So our equation for that is x plus or minus a half of b squared minus a half of b squared plus c. Let's do that then. So then we have y equals x, half of that, which is minus 3 over 2 squared. Take away that again, minus 3 over 2 squared minus 10, but awkward this time, some awkward decimals. So they're awkward fractions, I should say. Let's carry on with this then. So y is then equal to, actually, don't we simplify this, do we? We only need the x coordinate, which is this guy here. So all we need for that is the x coordinate is 3 over 2. If we did simplify it, you can simplify all this, you can get the y coordinate, but a lot of work, none of it rewarded. So x is just 3 over 2. And there we have it. Okay, last question then. We have the Edexcel November 2018 paper 1. So pause it, have a go, see how you get on. Okay, then so question 17. Here is a sketch of a curve. The equation of the curve is y equals x squared plus ax plus b, where a and b are integers. The points 0, minus 5 and 5, 0 lie on the curve. Find the coordinates of the turning point of the curve. Right, so we know that 0, minus 5, that's there. And 5 noughts, that's there. Okie dokie then. So this is then the y-intercept. So this b here that they've labelled it, should normally be c, but hey ho. Let's put that minus 5, that's the y-intercept. So we then get y equals, can't speak, x squared plus ax minus 5. Okay. And then let's put this point in so we can figure out what a is. So then we know that y is 0 in this case. We know that x is 5. So then we have 5 squared plus 5a minus 5. Just 5 times a, which is 5a. And then we have 0 equals 25 plus 5a minus 5. Which is 0 equals 20 plus 5a, take away 20 is minus 20 plus 5a, no it's not, minus 20 equals 5a, and then divide by 5, minus 4 equals a. Okie dokie then, let's build up our equation again then, so then we have y equals x squared minus 4x, and then what is that, minus 5. Then let's complete the square on this. Remember the equation for that is x plus or minus a half b minus half b squared plus c. So then we have y or x, and then half of that is minus 2 squared. Oh, keep hitting that squared, don't I? Take away, and then half of that squared is, so that's minus 2, square that is 4. And then plus c, which is minus 5. And then we then get x minus 2 all squared minus 9. So remember, change the sign, keep the sign. The turning point is going to be 2 minus 9. And there we have it for 4 marks. So there we have it. That was day 7 of my 25 Days to Better Maths Grade series. Hope you've enjoyed. If you have, Feel free to like, subscribe, do all that YouTubey stuff. Tomorrow we're going to be looking at solving quadratics using a graph. So stick around for that. So hope to see you tomorrow. Bye!